All right. The rest of you pay some respect, please.
Good morning, guys. Me and my team will be presenting the mathematics topic functions. So, firstly, what are functions and what is the importance of functions? Well, functions is a relation between a set of inputs and a set of possible outputs. And also, functions is a way of assigning to each input exactly one output. What are the importance of functions? Functions can be used to model and describe real-world situations, such as the motion of objects, population growth, and chemical reactions. Functions help us understand relationships and patterns between variables, which is crucial in many fields, including science, engineering, and economics. Now, I will post the Aguilera to the stage and to explain to you guys what exponential functions are.
Good morning, everyone. I was assigned the exponential graph. For many of you who doesn't know what an exponential graph is, an exponential graph is a graph of exponents. A trinomial is a graph, a polynomial is a graph. So of course, exponents have their own graphs. The exponential graph, the basic form for the exponential graph is like this. Y is equal to b exponent x, where b cannot be equal to 0. And b is bigger than 0. For example, let's take this equation, where y is equal to 2 exponent x. Three things you should do when you do an exponential graph. You need the x-intercept, the y-intercept, and the asymptote. The asymptote is usually a number which is here. For example, let's say minus 2. Then your asymptote will be here, minus 2. But for this graph, it doesn't have an asymptote. It does, but it doesn't at the same time. So the asymptote for this graph is there on the x-axis. Okay? The x-intercept of this graph, it doesn't have an x-intercept. If you're going to make y 0, you won't be able to solve it. But it does have a y-intercept. If you make x 0, and the answer you get is going to be 1. And the basic form of an exponential graph goes like this. And the exponential graph never touches the asymptote. Never. Now, every graph have inverses. That's what we learned in grade 12. Inverse. I don't know why I introduced it, but inverses. Now, for inverses, it's simple. Let's say our previous graph, we had 0 and 1, right? The inverse, you just switch x and y, then it's 1 and 0.
Yes.
Just like that. Now, the basic form for the inverse is logs, which you also learned in grade 12. Log, we first start with what we are given, which is this equation, right? So we just switch x and y. X is equal to 2, y. But remember, there's no graph that x is equal to. There's only y with your base. It's y, right? So we have to make this equal to y. So what do? We learn in grade 12, we can use logs. So we can say y is equal to log that base, include here, log 2 of x. Then this is your inverse of the exponential graph, which is called the log graph. Thank you.
So, as Gabriela said, that in grade 12 we are introduced to logs. So logs is laws, and the logs law are a set of rules or properties that govern the simplification of logs expression. Understanding laws of laws, your laws is essential for simplifying complex logs expressions and solving log equations efficiently. So there are a few log rules, there are product and all those stuff, but okay, there's the few log rules. So we'll just be doing a few. So the first the one that I'm gonna do is coefficient laws. Coefficient laws is log, for example, b of x minus log b of y, whereby since we are subtracting with the same basis, we're gonna divide the variables. So the product will be log b of x divided by y. This law states that the log of the equations of two different numbers is equal to the difference of the log of the numerator and denominator. So another law is the product. The other law is log b a plus. So since we are adding, the product is we're gonna multiply the variables. So we're gonna get log b of x y. Okay.
Okay, I'll also be talking about the logarithmic function. Logarithmic function is closely related to the exponential function. Specifically, the logarithm is the inverse function of the exponential function. The equation y is equal to log bx represents a function or the logarithmic function where the base b is a positive. In this one, the base b is a positive number. The domain of the function is 0 and positive infinity. The range of the function is negative infinity until positive infinity. The graph of y is equal to log bx is a curve that opens upward with a vertical asymptote of x equal to 0.
Good day, everyone. So I will be reviewing the linear and the quadratic function. So I'll start with the linear function. The linear function has an equation of y is equal to mx plus c. So this is the equation of a linear function where m is equal to the gradient, and the gradient is how steep or gradual the linear function will be. And the c indicates to us the y-intercept of the linear function. In order for us to determine the y-intercept of the linear function, we make x equal to 0. And when x is equal to 0, this immediately cancels this whole thing, equating y to c, which means that our y-intercept will be equal to c. For us to determine the x-intercept, we make y equal to 0 and we solve this part. A linear function doesn't have any asymptotes, it doesn't have a turning point, it only consists of the x coordinate and the y coordinate. So now I'm going to move over to the quadratic function. The equation for the quadratic function is y is equal to ax squared plus bx plus So when A is greater than 0, the parabola will be concave up. And when A is less than 0, the parabola will be concave down. A indicates to us the shape of the parabola. In the quadratic function, in order for us to determine the turning point, we calculate the axis of symmetry. We take B and we say negative B over 2A. And this is how we calculate the axis of symmetry. In order for us to determine the y coordinate of the turning point, we substitute this value into the equation and then we get the turning point of the parabola. So now I'm going to hand over to Eva to explain the inverse.
So how is y is equal to a x plus which is basically the same as y is equal to a plus 3. So a will be basically the same as graph and q is y is equal. So the inverse of y is equal to a plus 2 is equal to so the properties of this graph is that it reflects the graph of y is equal to x plus q.
I'm going to be doing a few examples on how to determine the inverse of a linear function in terms of y. So the first one is we have given y is equal to 3x plus 4. The first step, we have to change our x, swap our x and our y. And then bring over the 4 to the side. Since you want to get y alone, you have to divide by 3 with the whole measures. Therefore, this is the inverse of this equation. Another example is this is going to be y. And we change the term. Divide. And that is a inverse.
So how will we determine the inverse of the function? The reason for finding the inverse of a function is to solve the input given the output, allowing
us to reverse the function and find the original value of x that corresponds to a given value of y. So I will be making an example. This is the function. So the question is to determine the equation of f in the form